The Honda B Series remains one of the most iconic engines ever created, a true gift that kept on giving. While other manufacturers produced solid motors with impressive traits, Honda had something special hidden up its sleeve: VTEC. This clever system gave the B Series a rare combination: smooth idle and fuel efficiency during daily driving, and, when engaged, a high-performance cam profile similar to a race-tuned engine. The result was the ability to rev to incredible heights and produce power no economy-based four-cylinder had achieved before. Best of all, it was accessible to everyday enthusiasts. Affordable, relatively simple to work on, and paired with a turbocharger, it could deliver performance limited only by imagination. This is the story of one of the greatest inline-four engines in history, a motor that helped redefine Honda's image from a maker of economy cars and motorcycles to a platform built to race, to push to the limit, to brake, and to rebuild stronger. In the performance world, one golden benchmark has long stood as a measure of engineering excellence: 100 horsepower per liter from a naturally aspirated engine. Today, that figure is common among high-end exotics and even certain production Mustangs, but in the late 1980s, reaching it required pushing mechanical limits. That same decade, Honda had already proven its skill in building high-revving machines with the CBR 250R sport bike, a small dual overhead cam inline-four that spun all the way to 17,000 RPM straight from the factory. That's an astonishing 283 revolutions every second, and in terms of output, the equivalent of 180 horsepower per liter in 1987. It was a stunning showcase of Japanese engineering, especially for an entry-level motorcycle. At the time, Honda's passion for high-revving performance was mostly confined to its motorcycles. That changed when engineer Ikuo Kajitani, working at Honda's Tochigi R&D Center, set an ambitious goal: bring the magic of 100 horsepower per liter engines into the company's passenger cars. His idea centered on solving an age-old problem in internal combustion: that an engine's ideal valve size, camshaft profile, and intake design only work perfectly at one point in the rev range. Kajitani proposed using variable valve timing to make the engine efficient at both low and high RPM, effectively giving it two power bands instead of one. The concept used 3 cam lobes and rocker arms per cylinder, 2 tuned for efficiency and 1 designed like a racing cam. At lower speeds, the engine relied on the outer, mild profile lobes, but once the revs climbed, the ECU would trigger a spool valve, sending oil pressure to a locking pin that linked all 3 rockers. This engaged the aggressive center cam profile, unlocking a surge of top-end power. The engineering challenge was enormous, but as Kajitani himself admitted, while the goal seemed almost impossible, the team ultimately succeeded. Honda's innovative approach to performance reached a turning point with the introduction of a revolutionary system known as VTEC, short for Variable Valve Timing and Lift Electronic Control. The first production engine to feature this technology was the B16A, debuting in 1989 inside the Honda Integra XSI, as well as select versions of the Civic and CRX. Almost immediately, it captured the attention of driving enthusiasts worldwide. The concept was so effective that it kicked off an industry-wide race for competing systems. Mitsubishi answered with MIVEC, Mitsubishi Innovative Valve Timing Electronic Control, which used a more mechanically complex method involving a T-shaped lever and rocker arm pistons to alter valve lift at high RPM. It was clever, but it arrived 4 years after Honda's breakthrough, and the inspiration behind it was clear. The B-Series lineup eventually expanded into a family of engines with multiple displacements and configurations. The original B16A appeared in various versions, A1 through A6, while the highly tuned B16B, reserved for the JDM EK9 Civic Type R, pushed power density to new limits. The B17A1 lived under the hood of the Acura Integra GSR, while the non-VTEC B18A and B18B powered more affordable Integras. At the top of the naturally aspirated food chain sat the B18C and B18C5, found in the Integra Type R, capable of screaming all the way to 9,000 RPM from the factory.
On the other end of the spectrum, the larger displacement B20 engines, most often seen in Honda CR-Vs, offered torque over revs. Best of all, much of the B-Series lineup was interchangeable. This led to creative Frankenstein builds, such as pairing a lower-cost non-VTEC B18B short block with a high-flowing B16A VTEC cylinder head, producing a torquier version of the B16A without sacrificing its high RPM punch. The tuning potential of the B-Series became legendary. Aftermarket pioneers like Spoon Sports took the already formidable B16B from the Civic Type R, increased its displacement to 1.8 liters, fitted more aggressive camshafts, upgraded to stiffer valve springs, added individual throttle bodies, and recalibrated the ECU, extracting an incredible 260 naturally aspirated horsepower from a compact engine that revved to an ear-piercing 11,000 RPM. Turbocharging only amplified its potential. Since VTEC already had an aggressive cam profile baked in from the factory, there was no need to swap cams for forced induction setups. With a properly built bottom end and forged rotating assembly, 500 horsepower became an achievable and reliable goal. In extreme drag racing builds, B-Series power plants have even exceeded 2,300 horsepower, launching quarter-mile cars to 6.6-second passes at nearly 200 miles per hour. By the early 2000s, however, Honda began phasing out the B-Series in favor of the new K-Series engine architecture. The K engines brought modern touches like coil-on plug ignition instead of a distributor, a timing chain instead of a belt, and an updated iVTEC system. Unlike the original VTEC, which mainly optimized high RPM performance, iVTEC could advance cam timing at lower and mid-range RPMs, significantly improving torque without sacrificing top-end output. Like the B-Series, the K lineup became a playground for engine builders. A common example is combining a K24A2 short block from an Accurate TSX with a K20A2 cylinder head from an RSX Type S, a relatively affordable hybrid that when turbocharged can easily produce 550 to 600 horsepower with less effort than a comparable B-Series build. Today, the K-Series dominates the Honda tuning scene. B-Series engines, while still coveted, have become increasingly rare and expensive. Finding a clean B18C or C5 for a project car has become a near impossible challenge unless you're willing to pay a premium. While its production run was relatively short, the B-Series proved just how much performance could be extracted from small displacement engines. Its influence wasn't confined to Honda's either. The same VTEC principles were applied to Honda's other performance icons, including the NSX. The success of this technology inspired rivals across the automotive world, with systems like Mitsubishi's MIVEC and Nissan's VVL all tracing their roots back to Ikuo Kajitani's vision of altering cam profiles on a fly. The K-Series may now carry Honda's performance banner, but the B-Series remains the legend that started it all, an engine that blended everyday usability with motorsport DNA and forever changed what people thought was possible from a compact four-cylinder.